In this question, they give us a differential equation, dy by dx minus 3x squared minus 5 e to the 5x equals 2. This is an equation because it has an equal sign, and it's a differential equation because there's a derivative in it. And they also give us some other information that says that they want a function y such that when you plug 0 in for x, the result of plugging 0 in for x, you'll get 7. And what they're saying is that this function, y of x, this actually makes the differential equation here true, but it also makes this extra piece of information, y at 0 equals 7, true. So let's just double check. They're saying that this function solves these things, so what we need to make sure is that the function that they've provided actually does make these things true. So the first thing to show is that the function that they gave us is actually a solution to this differential equation. So we're going to figure out, we're going to plug in this y of x into this differential equation. So let's just take the derivative dy by dx because that's in our equation. So let's just actually see what that is. So according to our given function, the derivative of y with respect to x should be 3x squared, because the derivative of x to the power of 3 is 3x squared. Plus, using the chain rule, we have 5 e to the 5x. The derivative of 2x is just 2, and the derivative of 6 is just 0. And so if I simplify that, I get 3x squared plus 5 e to the 5x plus 2. Okay, so we know, given y, we now know what dy by dx is. So now we can actually see if this fits in our differential equation. So into the differential equation, into the dE, what we see here is we have 3x squared plus 5 e to the 5x plus 2. That was our dy by dx, so that went in for dy by dx. And then the rest of the equation is minus 3x to the power of 2 minus 5 e to the 5x, and that's supposed to equal 2. So let's just simplify things a little bit and see what happens. This 3x squared minus 3x squared goes away. This 5 e to the 5x cancels with this negative 5 e to the 5x. And so at the end of the day, on the left-hand side, I'm left with 2, and on the right-hand side, I'm left with 2, and certainly 2 equals 2. So this definitely makes the differential equation true. However, that's not the whole story. What we also need to make sure is that that y at 0 is equal to 7. So let's actually plug in x equals 0 into their y. So we have 0 cubed plus e to the 5 times 0 plus 2, 0 plus 6 equals 0 cubed is just 0 plus 5 times 0 is 0, so e to the power of 0 is 1, plus 2 times 0 is 0, plus 6, and if I add all that up, I get 1 plus 6 is 7, and that's exactly what we were supposed to get when we plugged x into, or 0 into x, and so this indeed solves the differential equation that they gave us.